In this video, we're going to talk about how to prove or verify trig identities. And the trig identity we're going to look at in this problem is the sine squared x multiplied by 1 plus cotangent squared x is equal to 1. And the general strategy when you're proving or verifying trig identities is you want to pick out the uglier or the more complicated side, which in this case, of course, is the left-hand side of the equal sign. And you want to work on that left-hand side using various techniques of algebra and the trig identities you see over here on the right-hand side of your screen to simplify it and change it and transform it to where it turns into, in this case, a 1, or to where it matches the other side of the equal sign. And so that's what we want to do. And generally when I'm doing these problems, I look to see if there's any kind of algebra that I can use first of all, like some sort of factoring or whatever. But for this particular problem, there's nothing we can do in terms of factoring or just algebra that wouldn't make the problem more complicated. So the next thing I'm going to do is I'm just going to look and kind of scan over the trig identities you see on the right hand side of your screen. And I want to see if there's something that kind of matches out, something that we can change out. And we kind of get lucky in this problem because we have 1 plus cotangent squared x in the parenthesis, and you can see that that matches up with the Pythagorean identity cotangent squared x plus 1 is equal to cosecant squared x. And of course cotangent squared x plus 1 is the same thing as 1 plus cotangent squared x. And the idea is anywhere we see that, what I have underlined once in red, we can exchange it for cosecant squared x, what I have underlined twice in red. And so that's going to be our first step for this problem. Is we're going to have sine squared x, just bring that right on down, and then instead of 1 plus cotangent squared x, we're going to have cosecant squared x. So all we did was change out something on the left-hand side. And keep in mind, the idea is we want to simplify it as much as possible and transform it into what we see on the right-hand side, which is 1. So now the next thing that I see is we kind of broken everything down. We just have sine squared x and we have cosecant squared x. And so the next thing that I think of is, well, cosecant x is the same thing as 1 over sine x, which you can see up there, one of our reciprocal identities. But of course that would mean that cosecant squared x is the same thing as 1 over sine squared x. And so that's what I'm going to exchange out this time. So again, just bring down the sine squared x. But in the place of cosecant squared x, we're going to have 1 over sine squared x. And from this point, you may be like, oh, I see what's going on now. Just exchanging out those two different things allows us to cancel out the sine squared x on top and bottom because we have multiplication. And all we have left over is just a 1. And so that matches the right-hand side of the original trig identity. And so now that we have a match, we have now verified or proven that that does indeed work. So again, just kind of, rehashing this, sometimes there are a lot of different paths you can take to get to the answer. Sometimes you can do it in a few steps, and sometimes you could, instead of doing it in a few steps, you could do different things and make it a bunch of steps. I typically try to sit back and look at it and think about how to make it, work out the easiest or the fastest, but you certainly don't have to. There's some flexibility and some creativity you can use in these problems. But in general, when I'm doing a problem like this, pick out the worst looking side, the more complicated side. Try to use some factoring first if you can. Try to use your trig identities to change some things out. And then ultimately, it's generally a good idea to get everything in terms of sine and cosine at the very end because a lot of times that'll make it work out. So that's it. That's all we have to do for this problem.